my name is Russ Manning, and I'm going to be giving this short overview on building information modeling objectives for the military healthcare system. This is titled BIM 102. If you're interested in more details on the objectives and how they apply to the MHS, I would encourage you to watch BIM 102 Extended. If at any point during this presentation you need more time on a particular slide, I would encourage you to hit pause and then play when you're ready to continue. As we talk through the BIM objectives, it's key to understand the importance of facility lifecycle management. The project supports a solution to a requirement which is driven by a defined mission for the MHS. There are many parties from planning and programming through design and construction into operations who use common data at various periods over the facility lifecycle management. The problem is, historically, at each one of these stages, most of those parties end up having to recreate the same information rather than share it or augment information that's been developed before. Currently, the MHS has 9 BIM objectives, guiding the use of BIM to support definitive outcomes or improvements synchronized over the facility lifecycle management. We're not doing BIM just for the sake of BIM. The first objective relates to level of detail. It provides clear expectations for the team on the level of detail for each submittal associated with the BIM. We're trying to use standard expectations of information to reduce confusion, such as AIA standards, Building Smart standards, or VA standards, to the extent that they exist to help clarify level of detail. One example of where level of detail applies is having the correct level of detail at the correct submittal to ensure that we can do collision detection or interference coordination. The next 4 objectives that I'm going to discuss relate to bringing information from our corporate planning system, SEPs, into the design and construction process, validating it during that execution, and then taking information from the project back into our corporate systems. I may refer to these as blue dot and red dot. This takes us to objectives 2 and 3, validating the program for design and the project room's content, something that's already done multiple times during the design process with or without the use of BIM. However, BIM enables this to be done in real time. It increases the accuracy in that effort and the confidence in those results. Because it's automated, it also reduces the redundancy of the effort during the design process. We take project-specific PFDs and PRCs developed from our space and equipment planning system and hand those to the designer to be incorporated into the design. That information is then compared against the design at various times during the submittal process. The same thing happens with the project room contents, or the medical equipment and furniture. There are many solutions out there using BIM that can automate this process. One example is demonstrated in BIM 102 Extended. Objectives 4 and 5 look at bringing the information that's project-specific back into our corporate systems, both for facilities management and medical equipment management. This is a process that we have to do on every project currently. However, it's unique and one-off to each project. BIM enables us to set up a process that allows this to happen in a uniform manner, allowing it to be more timely and accurate. This is a simple diagram showing the concept behind objectives 4 and 5. We have project-specific information that may be directly in the BIM model, it may be linked to the BIM model, or it may be in multiple BIM models. We need to have a common language or a Latin to bring that information across to our CMMS system, which for the MHS is DIMLS FM. The Construction Operations Building Information Exchange, or COBE, is an industry standard that will allow us to do this. The same concept applies to Objective 5, bringing information on our medical equipment into our DIMLS ET&M, our medical equipment management system. Objective 6 looks at using BIM to enable and support effective energy analysis planning and design in fabrication and operations. This is detailed more in BIM 102 Extended. Many of the BIM platforms or applications available today have linkages to support this process both to Trace 700, HAP, and many lighting and daylighting applications. Objective 7 looks at using BIM information to support an informed planning process or providing a planning feedback loop to inform our criteria, guide plates, our net to gross, our costing, our utilization, and our capacity information in a more real-time fashion. Objective 8 looks at using the information available in the BIM model to help inform and streamline our initial outfitting and transition process. Objective 9 is key to the entire facility lifecycle management. The MHS needs to continue to participate in the AEC industry to ensure interoperability of information among the BIM platforms and applications. Thank you for your time and interest. For more information in BIM in the MHS, I would encourage you to use the link listed here. For more details on the BIM objectives discussed in this short video, I would encourage you to watch BIM 102 Extended. For a basic overview of BIM, I would encourage you to watch BIM 101. There's also a great many resources available in the Whole Building Design Guide relative to BIM and other criteria associated with federal projects.